This is Riley and Max's final physics project for 111A.
Sweet. Alright, so first off, I can explain the bread and butter. We have this thing called a Colpitts oscillator circuit, and it's located right over here. And what we did was, instead of using a quartz crystal as it recommended us to do, instead we just went to the basics and actually just made our own oscillator.
Using an RLC.
Right, so resistor, inductors right here, and capacitors. And then from there, we... Nice. And then from there, this particular signal gives us this.
So we're gonna show my lab mates blasting music for us.
This is our oscillation right here.
So this is what. So these are turns of conducting wire, like electrical wire,
Right.
turned about 100 times each, and because the electrons pass through them at a certain rate, it actually produces this up and down effect.
Right. And it's not perfectly signed. That's probably because of the amount of amount of loops we have.
We made
on
them
the
with
inductor.
love ourselves.
Exactly. It took us freaking 30 minutes each
Yeah.
to make it, but that's fine. So
Riley, what are these blinking lights?
yeah, but first, before we go to the blinking lights,
Oh, okay.
we had to amplify our voltage because the blinking lights weren't working initially. And it's displayed right here. This little doohickey right here is our it's called a non-inverting amplifier. So it amplifies the circuit or our signal to where it'll increase in voltage. So from there, if you look at our lights, that particular signal goes to these things called 555 timers, which Max initially proposed, and it's actually really, really handy in terms of blinking LEDs. So this one, in theory, blinks about 0.1 every second. This one, this green one blinks every 0.7 seconds, and this one blinks every about 5 to 6 seconds. And we can visually see this going on. So of course this one's it's longer, it's about 5 seconds, and it shuts off for 5 seconds and turns back on for 5 seconds. And these LEDs right here, it's just for aesthetic reasons. It's just a visual display of decreasing LEDs.
So it's a little bit hard to see in the video, but what we have is basically brightest to least bright. And if you guys look, you can see that each of these guys, these resistors, are different colors. And so over here we have a resistor that's pretty small, it's only a couple of thousands of ohms. But this one over here with the green band is over 1 mega ohm, so that's over 1 million ohms of resistance.
Yes. Yep. And then that's essentially the bread and butter of our circuit. And if you want to see this guy, this is a separate oscillator using a single op amp. And
it uses the quartz crystal. So
Right.
earlier we saw the kind of shaky sine wave.
Right. And let me trigger really quick.
And so that yellow one is the bad one, but that we made ourselves. And this is the very clean signal that we get from the quartz crystal. And a quartz crystal is the most accurate type of clock you can get, short of an atomic clock that's used on
And they look like
GPS
these. So the ones we're using right now is these low frequency oscillators, which you can see it's
very clean.
very clean, pretty low.
Rubidium clock.
Rubidium clock.
So
It's good. It only costs you about $2
Right. And this is Sean, our GSI.
Yeah.
We're making a video.
For our family and friends.
Okay, yeah.
So what we have over here is the application of our quartz crystal, because I told Riley that what was really important that I felt is that we actually did some science, that we couldn't just make a music equalizer or make a subwoofer or a machine arm. I wanted us to do something that had tangible results, and so what we built was a logic gate, the basic binary parts of a computer. So if you see these, it goes 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. And this light will stay on while they blink and turn off again. So it's additive. And this is the basic building block of how a computer works. Then from here, we have 2 oscillators. These two blink at this guy blinks twice as fast as this one. You can see that on the screen. You can see this guy go up and down, up and down. And in the yellow, we see this happening twice for both times the blue does it. Now we can show this again for the last two. And we can see this effect multiplied. And so that's how a computer will work. You just have billions of these type of transistor gates, and right over here, if we zoom in, if I try to cover up these lights a little bit, this guy right here, Riley and I helped solder this together, and that's our quartz crystal, personally custom made to fit inside our circuit. So this is our physics project for 111A, summer of 2018. Riley managed to spend 10 weeks with me, and now all we have to do is type up a 50-page lab report.